Okay, so the first question requires you to determine the required magnitude and of force FB and its direction theta. That is the example that is given in the question. But now the real question needs you to find a system where two or more forces are applied at a single point. Like for example, if you can, as you can see in the question, these are two forces, FA and FB, that is applied at a single point to pull this object. Now you're told to find an exact system that looks like that. Now can compute the resultant force and determine the direction, the magnitude and direction. Now using the approach an approach that is similar to what the question requires, we can use this example, because we can see that these are two forces that are applied and they are pulling this object. Now the difference here is that you are being told that the resultant force, the magnitude of the resultant force, and the direction. That is, it is the resultant force is 3 kilonewton, as you can see from the example. It's 3 kilonewtons, and the first force is known, and its direction is known. But now the second force is B, and its direction is not known. Normally, if you are not given the resultant force, you can compute the resultant force by decomposing. For example, if it's because these are two forces, assuming that it was only one force Fm, you can decompose Fa into its respective x and y components. So if you have the x component of this force, which is given by the cos of this angle, and the y component of this force, which is given by the sine of this angle. Remember, all angles are measured from the x-axis, no matter the direction. If it's this your x-axis, and you want to determine the x component, you will use this angle. If you want to determine the y component, use the same angle, not this angle, the same angle. The same case applies for the force B. If you want to determine the x component of FB, you'll use this angle. Remember, it's measured from the x-axis in the direction of that that particular force that we are looking for. So you will get the x component using the cos of this angle, and you get the y component using the sine of this angle. Now moving on to solving the question at hand, you are given the resultant force is 3 kilonewton. The resultant force, and which occurs along the x-axis. Remember, in real life, you'll find that this is a boat and this is another boat, and they want to either pull an object either from the deep in the ocean or inside from the shore and pull it towards the ocean, or the other way. Now, let's say that a single boat cannot be able to pull this object, but now they require another boat to reinforce this another one so that they can be able to pull this object. Now this question now requires you to find, because you see this is a force that is applied at a single point, and they are pulling it at different angles. It could be the same angle or different angles. It will depend on what you want to achieve. Okay, so having that in mind, let us now proceed to solve our question. You are told if the resultant force of the two tugboats is 3 kilonewton directed along the x-axis. Now, since there is no resultant force along the y-axis, that is obvious because you are told they want to pull this in this direction, not this direction. So they do not need any force that is going to wastage. They only need to have a resultant force going this way. So because there's no resultant force along the y-axis, we'll have the resultant force along the y-axis equals to 0, right? And that is why I've said here no y-axis component of the resultant force, because it is already in the along the x-axis. Since the resultant force along the x-axis is 3 kilonewton, the resultant force F of x along the x-axis, the resultant force along the x-axis is 3 kilonewton. Very obvious, we are told that. Now, you can make a diagram to represent these forces as vectors. You see, when you're taught to represent a force as a vector, it means, because force is a vector, it has both magnitude and direction. So you need to plot that in a Cartesian plane, whereby you have the force facing the direction in a certain direction and having a given magnitude. Because the magnitude of Fa is known, right? Isn't it? The magnitude of Fa is known. Let me see, where is it? It's 2 kilonewton, right? Yeah, it's given the diagram. Yeah, I couldn't see that. It's in the diagram. So if I wanted to represent this as a vector, to represent the force as a vector, I'll draw something like this. That is my Cartesian plane, and this force Fa, I will draw an arrow equivalent to the number of units of that, the magnitude of that force. I'll draw it like that, and that give it the angle that is required. So this is 2 kilonewton, and this is 30. I have represented Fa as a vector because I've given it a direction and a magnitude. Now this is the size of this arrow must represent a force of 2 kilonewton. That is how you represent your force as a vector, right? Now you are told on the diagram, plot the resultant force applying the parallelogram law. Okay, we will now that is depending on the whatever that you want to give us your response to that question, that particular question, because whatever that we are determining here on this example on exercise 2.28 could be a little bit different, but I'll show you that. I'll show you how you would determine the resultant force applying the parallelogram law. For example, let me try to do that here, so that I don't forget. So when we apply the parallelogram law, we do that when at the moment we have two forces, okay? Because we are taught to use two forces. So this is the second force, okay? Now, how does a parallelogram look like? It has two opposite sides that are equal, right? And they are parallel. So you would draw a line that is like this one, that is parallel like that, and a line that is parallel to this one. Now, the resultant will be given from this tip to the other tip. That will give you the resultant. The resultant. That is you have applied now the parallelogram law, because this itself is a parallelogram. So from this point to where these two forces are meeting, that is the resultant force. And to get the magnitude of this resultant force, you will take the x component of this, which is given by this angle theta here, the x component of this force plus the x component of this force, okay? And there is another formula here that we apply where we say the magnitude R is equals to, because we say it's the resultant along the x-axis, frx squared, plus fry, the magnitude along the x-axis, squared, square root. You'll get the resultant. But that is not our objective for this one. Let me proceed to solving our problem at hand. I've gone ahead and represented a particular problem in a diagram, or in a diagram. So for the first force Fa, we have its direction 30, and we have the magnitude is 2, because we are told it's equal to 2 kilonewton. Okay. Now I've decomposed this force into x component and y component, whereby I have Fax, the x component of this will be given by the cosine of this angle, so which equals to Fa, which is that force, the magnitude of that force, which is 2, times the cos of that angle. And for the other one, the x component of this force will be given by the cos of this angle, so we have Fb, magnitude of this force, and the cos of this angle, which is unknown at this point. The other one, because the direction is like that, so because it is in the positive direction of the x it is in the positive direction of x and the positive direction of y, so we have the y component going up like that. Okay, because this is a single force. Now we'll solve it. There's a method that we just use. This is basically another parallelogram, because this side and this side they are parallel, and this side and this side they are parallel, and we'll assume now this is your resultant. Now if you want to decompose it, you break this one into x, into y and x components, by simply taking the coordinates for those points on the respective axis that you are working on. So because this one is in a positive direction, we have the force pointing upward like that. So Fay is given by Fa multiplied by the sine of this angle sin 30, right? I've said that is in positive direction. But if you look at this one, it is pointing the positive direction of the x-axis, and at the same time it's pointing at the negative direction because it is below the x-axis. So this side of y-axis is negative, alright? I've said here it's negative. So it will be given by Fby is equals to Fb, the magnitude times the sine of this angle, not this one, but the respective force, this angle from the x-axis, always. Also remember that when we are determining the direction of the angle, we always measure from the x-axis, the acute angle, the nearest acute angle to that force. So if I had a force here that is going this way, because this is my x-axis, now this will be the angle that I'll be using. Okay, let me call this one phi. If I had a force that is going this way, now my angle of interest will be only this one. For this particular force, my angle will be this one. For this one will be this one. Even if the force was facing this way, it is up to you. You may decide this is 90, also this one is 90. It's up to you. So basically I was trying to define so that you may always angles always taken from the x-axis, nearest acute angle. I've given a note here. Horizontal component of force given by the F cos theta, that the angle that you are interested in. The vertical component is given by the sine, and now force is a vector quantity, hence sign changes with the direction. If it is pointing in the negative direction, we'll have the sign. When we are computing here, we'll introduce negative here, we'll introduce negative wherever the force is pointing in the negative direction, because we are summing. When we do sum, we are adding something that is negative, you will get definitely get a negative. So that is why you see here it was a plus. And as I proceeded with my calculation, you see that it is turning to negative. We'll see that. Let's start now solving for to determine the magnitude of force B and the direction theta. Alright, very good. The x component of the resultant force Frx is given by the sum of the x components of the two forces. The x component of this, that is now this one. So the resultant force, that is as a result of these two forces acting together, as a result of these two forces acting together, we'll have a resultant force that is a single force that can represent the effect of these two forces acting together. So we have the x components. Now when you add them, they will give you an x component that will represent that the two forces. So that is now we're having a single force. That is why we're having a single force Fx that is represented as a sum. See, as a sum. The resultant force is broken. Is represented. Is representing the two forces. The two forces. Okay. Having said that, now we proceed. Because we have already broken down the x and y components, now we have the resultant that is in the x-axis that is already known, because the resultant in y is 0. The Frx is 3, definitely. Okay. So we have substituting for this one, we'll have 3 is equals to this plus this. Okay, and because this one is known, we represent with its known value, but these and these ones are unknown, so we'll stick by that. So because we cannot proceed from there, we will call this one equation 1. All right, we will apply some other techniques so that we can determine the FB and theta. I've given a note here that says there are two forces, FA and FB. Both have x and x component. Right, because they are facing on a plane, xy plane. They both have x and y component because it is going facing this direction. If it was facing towards this direction, it would not have a y component. Why? Because it is not in the xy plane. Okay, it is not in the xy plane. This is xy plane, xy plane, xy plane, xy plane. This is only along the x-axis, so the y component will be 0. Right? At least simply that. We have already gotten our equation 1. Now the resultant force on the y-axis does not exist. Thus, since the vertical forces are in equilibrium, okay, what this means is the resultant force on the y-axis is 0, right? And since the vertical forces are in equilibrium, what does that mean? It means, because the question is already telling us that when these forces are acting together, this object is expected to move this way. Okay, so it means that the y component of this one and the y component of this one is balancing out with this one, so that the resultant along the y-axis is 0. When you have an equilibrium point, it means that there's no resultant motion, there's no movement along that y-axis. Okay. We say that Fry, which is given by the sum of the respective y components of those forces, is 0. Okay, so that is why we are saying here now the purpose, now the effect of the direction now is being felt here. So we are summing the y components, which are given by sine and sine. All right. And we equate that to 0. Remember the other one we equated to 3 because we have a resultant in that direction. That means it's a movement along x direction only for this one, for this question. Okay. It depends on whatever you are working on, but on this question we already know what we are dealing with. So because we do not have this force b and theta, we cannot solve any further, right? So we call it equation 2. So we working with what we know so that we can later get what we don't know, right? We can solve for sine theta from this point. So why? Because this one is 0. So if you move this one to the other side, we can solve. So let us see. This is here. This we take to the other side, becomes that. Alright. This was just for your explanation, so that we say sum is 0, so it means that they are equal, but they are opposite. They are equal, but they are opposite, because one is negative, one is positive, so they are balancing out. So from here we can solve for FB by dividing here by saying wait. We can get FB sine theta, which is this one. Now assuming we are working with this one, we say that the value is given by this. Okay, FB sine theta, the whole of this is given by this, which is 1 kilonewton. So FB sine theta is given by 1 kilonewton. We call that equation 3, because you cannot work with two unknowns. You cannot solve that. So now moving on to using what we have to get what we don't have. So we solving for FB equals theta from equation 1. What does equation 1 say? Equation 1 says that. Okay, how will we solve that? Let us see. So we have equation 1, FB sine theta is 1 kilonewton. We have said that is equation 3. Now let us solve for FB equals theta. So we want to use these two equations, equation 4 and equation 3, to be able to get theta using those two equations. Alright, so I went ahead and gave you this approach whereby we just divide. We can divide equations to solve an unknown parameter. Like for this one, we are dividing, so the FB and FB goes, and we know mathematically from trigonometry, we know that sine theta over cos theta is equal to sine theta, tan theta. So I've given this one, sine theta over cos theta is equal to tan theta, and now this tan theta now equals to this value. So when we solve for theta, we'll just using the normal trigonometric identities, whereby we just taking, if tan theta is this, now the theta is given by the tan inverse of that. I just computed the whole of this in my calculator, and then I got 38. If now this one is difficult for you, there's another pretty simpler one, whereby we're saying if we have these two equations, okay, and it's just the same thing. Okay, we have these two equations. We can say we can represent FB in terms of cos sine theta, and when we have this FB as a known value, we represent it here and now solve. How? Let's see, follow along. We have FB sine theta will be given by 3 minus root 3 over cos theta. Okay, now come and represent this on the other equation. Okay, so FB now is going to be represented by this. So we say 3 minus root 3 over cos theta. I hope you can see. Cos theta is equals to now multiplied by the sine theta, multiplied by sine theta is equals to 1. Okay. Now we can actually simplify further, say that this one divided by the, okay, let us divide this side and this side by this value. So when you divide this side, you remain with sine theta over cos theta is equals to 1. Now this one goes to divide this other side because it will cancel here. We have 3 minus root 3, and this one divided by, we know from trigonometry that sine theta over cos theta equals to tan theta. So tan theta is equals to this value. So from there we can now get our angle using tan inverse. It's equals to 1 over. It's basically similar to what we had earlier. I was just showing them that it's possible for you to divide equations and be able to solve a known parameter. So having determined theta, this theta now represents the right direction of SB, because you have solved for that angle that is on the Cartesian plane here. This one, we have solved for it. Now, because we know theta, we can now solve for force B. How? To get FB, we are going to use equation. We can use any equation as long as it contains FB inside. So, for example, we have so many equations here. You have equation 1, and you also have equation 3, right? You can come here and substitute for theta here and equate it to 1 and solve for FB. So we have FB is equals to 1 over sine 38.26. It definitely give you FB. Okay, yeah, because wherever we have FB, even here, we can solve for FB. It just it's the same equation. It's the same equation. Let's see. FB here, you can substitute the value of theta here, the 8.26. So this value divided by cos theta, you get FB. So whichever the equation that you're going to adopt for you to solve the FB, doesn't matter. It will always lead you to getting the correct value of FB. Okay. So to simplify things, I went for equation 1 and just substituted what I have, because it's only theta that is missing this equation. Then I solved for FB. Okay, so theta is the 8.26. I just substituted it directly, and then I made this subject of the equation. We have FB equals theta is equals to 3 minus this. Okay, so when I solved for FB, I got FB is just above FA. Or below, just below, because FA is 2 kilonewton. This is 1.6, so it's just below. I gave you a bonus. Another equation that you could utilize is this one, whereby there is an existing formula for finding the resultant force, whereby Fr is given by the square of the x component of the resultant force plus the s component of the y component of the resultant force square. Because we know Fr, which is our resultant force, we are given is 3 kilonewton, and we know that also the x component of the resultant force, we are told it is the 3, which is here, and Fry is given by question 2. Okay, where's question 2? Question 2 is right here. It's right here. Right here. So Fry is given by all this, which is equals to 0. We said that the resultant along the y-axis is 0, so the value of Fry is definitely 0. You're not going to use this, you're just going to substitute 0 directly. So yeah, what do we have? We have we've said this is 0. Yeah, it should have just substituted here 0. So no, we cannot substitute 0. We are solving for FB, because we cannot say it's 0 because we don't have the value here. We're solving for that FB. Okay, so I substituted all of it. So when I substitute for all of it using FRY, I squared it because I have FB inside. I can solve for it. So here, when this one is this one, they are going to subtract. So the remaining 0 is equals to whatever you have here on the right side. So square root of this side, square root of this side, square root of 0 is 0, and then the square root here disappears. So we just have the same equation. So when you simplify these, you're going to get that. Definitely. Okay? That's for question 1.